Hello, math students. Today we're going to be going over the first tutorial in Unit 2. And if you made it through Unit 1, congratulations. I feel like this unit is much easier. I feel like the first unit is kind of the hardest in my opinion. But after this, we're going to mostly deal with graphing, graphing lines, graphing all kinds of things. But I want you to really pay attention to this unit because if you get a good foundation for graphing in the beginning, it's going to help you move through the rest of Algebra 1, move through the rest of the algebra concepts that we're going to use. And it's really going to help you basically with everything else. So just follow along and do everything I do, write everything I write, and I guarantee it'll make a lot more sense. I know it takes time, but I'm telling you, it's definitely worth it. Okay. So let's go ahead and start this one here. It says, Brianna is excited because she has just been hired by a family to babysit on Saturdays. She's looking forward to earning some extra spending money. The family will pay her $12 per hour for a maximum of 8 hours. Brianna makes a table to show her earnings for 4 different numbers of hours. Help her complete the table. Okay, so basically if she works 5 hours, how much will she earn? Well, the key thing here is that she earns $12 per hour. So you do 12 times the number of hours, and that'll give you the amount she gets paid. Okay, so we'll put P here for pay. Okay, so if we do $12 times 5 hours, she'll get paid 60. Okay, 12 times 5 is 60. Let's go ahead and fill out this other one where she works 7 hours. So you just do 12 times 7, and this will tell you that how much she earns if she works 7 hours. So this ends up being 84. Okay, now what about these ones? Well, these ones, they tell you how much she earned. We need to figure out how many hours she must work. So if we, again, look at this equation, this time they're giving us the pay. So 12H equals, and the pay is 72. Now, hopefully you remember from the last unit, how would we solve this equation for H? Well, I hope you see that we would divide by 12, giving us that the number of hours she needs to work is 6. Solving this last one similarly, $12 times the number of hours, in this case equals 96. So how many hours would she have to work? Well, we're going to divide both sides by 12 to get H by itself using the division property of equality. This gives us 8. So she must work 8 hours to earn $96. Okay. This is page 5 of the tutorial. So we're going to move through the tutorial pretty quickly. Just kind of skip ahead until it stops you, and we'll go over those problems as they come up. Okay, the next part that really stops you is page 13. So you can just skip ahead all the way to page 13 and we'll go over this material. Which statement about the relationship shown in the graph is true? So you can see this is price of tomatoes. Okay, so you can see here the y-axis, that's the vertical axis, okay, is total price in dollars. So you can see the price is going up as we go. Then it says the tomatoes purchased in pounds. So the more pounds of tomatoes you buy, the more the price increases. Well, that makes sense, right? If you buy more tomatoes, it's going to cost you more money. Okay. So, but which one of these is the dependent variable? So we're going to talk about independent versus dependent variable. So one thing I like to think about is what makes more sense in a sentence. The price depends on the number of tomatoes bought, or the number of tomatoes bought depends on the price. Well, I hope you can see that the first sentence makes more sense, that the amount of money you pay depends on the amount of tomatoes you buy, right? So the y, the amount of you pay, is the dependent variable because it depends on the number or the pounds of tomatoes, right? Whereas the tomatoes purchase is the independent variable. Now, when we're thinking dependent, independent variables, generally speaking, the independent variables go along the x-axis. So usually we have the independent variable along the x-axis. We have the dependent variable along the y-axis, okay? So here, the total price depends on the number of pounds, okay? The total price that you pay depends on the number of pounds of tomatoes. Okay. Okay. At a grocery store, bulk almonds sell for $3.80 per pound. The cost Y in dollars of X pounds of almonds is shown in the table. Okay, so if you look at this table here, we can see 0.5 pounds, so that's half a pound of almonds costs $1.90. Well, that makes sense. Half of this per pound price, right? 1 pound costs $3.80. Again, that makes sense. 1.5 pounds, $5.70. 2 pounds, $7.60. Okay. Basically, you're just multiplying however many pounds times the price per pound. Okay. The relation described in this table is, I think what they want is continuous here, or is it discrete? This is a tricky one. The domain of the relation is x value is greater than or equal to 0. And the range, y value is greater than or equal to 0. Let's see. Yeah, okay. Now, what do these things mean? Okay, so let's first talk about domain and range. Domain and range. Domain represents what values your x could be. All right. Now, here we have some x values, but are these all the x values that x could be? Well, no. You could buy 5 pounds. You could buy 20 pounds, right? You could buy 0 pounds. So that's why the domain of this relation is x value is greater than or equal to 0. So you could have 0, you could buy 0 pounds, right? But you can't buy negative pounds. You can't buy negative pounds of the almonds, right? So because of that, 0 is the lowest value, but you can buy more than that if you wanted. Similarly, the range is the y values, in this case, the price. So you could see there's some prices here, but that's not all the prices that could happen, right? You could pay 0 if you buy 0 almonds, and then the price goes up, so forth, right? Okay. Now, is this relation, the relation described in this table is, we would say, continuous. So a continuous relationship, basically, think about these x values, okay? Think about these x values. We could have 0.5, but you could have 0.51. You could have 0.52. You could have 0.53, right? You could have any number in between there, not just discrete amounts. So discrete amounts are like, you could only have 1, 2, 3. Like the number of people in a room is going to be discrete amounts because you can't have like fractional amounts. But continuous does have fractional amounts. So you could have, in case of weight in pounds, that's an example, pretty much will always be continuous because you can be more than just like 1 pound, 2 pounds, 3 pounds. You could be like 1.105 pounds, right? Or 2.03375 pounds, right? So any decimal you could think of can fit in there. Well, besides negatives in this case, but yeah, so things that are continuous are usually like weights, time. So things that are measured can be split up into smaller and smaller portions is continuous. All right, it'll make more sense as we go, but I don't want you to stress too much. The main thing I want you to know is this domain and range. Again, the domain talks about what x values are possible. The range, what y values are possible. We're going to be looking at domain and range quite a bit throughout the rest of this unit and from looking at graphs as well. So let's go ahead and take a look on page 23. It says, imagine that this graph represents the distance Brianna travels to get to her babysitting job with respect to time. Describe a relation that the graph may represent. So you can see time is along the x-axis. Usually, if time is one of your variables, it almost always is going to be on the x-axis because time is an independent variable. Distance from home, miles. Okay, so we could see, all right, well, we have a line with a slope here, okay, then a flat horizontal line, and then it continues up like this, right? So describe a relation that the graph may represent. So something like, so let's look at time. Basically, I just want you to describe it, right? So, and where time is in this case, minutes. Okay, time is in minutes. So in the first 6 minutes, comma, Brianna traveled. So in the first 6 minutes, she traveled 3 miles at a constant rate. Then once she got to this distance, she basically spent some time without moving at all, right? So during this flat horizontal portion, time is still moving, right? So she's basically just standing there or sitting there or whatever, right? Maybe she's at a stoplight for a long time, right? So here she is, she's sitting here. During this whole time, she's still 3 miles away, right? So after that, she does not move for 4 minutes, it looks like. So from minute 6 to minute 10. That's a long time to be sitting at a stoplight, but whatever. And then from minute 10 to minute 16, she travels how many miles? So from mile 3 up to mile 7. So travels 4 miles. Okay, so that's just describing what this graph is basically telling us. Okay. In which piece was Brianna traveling the fastest? So was she traveling the fastest during this time, or this time? Well, you can tell the speed that she's traveling. Basically, it's the slope of the line. So the steeper the slope, that means the faster she's traveling, right? Which makes sense because if you have a steep slope, that means you're traveling less time, but more distance. So you're going faster. You can see which of these sections has the steepest slope. Well, that would be this section right here. Let's look at part C. Use the graph from part A to complete the statement. In this situation, time is the independent variable and distance is the dependent variable. Remember, if time is involved, it's almost always going to be the independent variable. And also the x-axis shows us the independent variable. So once again, we can see on the x-axis, time in minutes is our independent variable. That makes sense. Okay. Well, that's it for the tutorial. Once you've gotten that done, we're going to go ahead and work on the practice and the mastery test. So go ahead and open up the practice, and we're going to go over all the practice questions here. All right. Let's go ahead and do that. Now, again, write down everything I write, do everything I do, and I promise it'll make more sense. All right. The graphs below show the sales of touchless thermostats. Why? Okay. For the first 8 months last year. Both graphs show the same information. Okay. So we have both graphs showing the same information here. Okay. Samantha is preparing a presentation and wants to emphasize that the sales increased slowly over the first 8 months last year. Complete the following sentences. To emphasize the slow increase in sales, it would be best for Samantha to use blank for her presentation. So which graph looks like a slower increase in sales? All right, that would be graph A. So if she wants to show its slow increase, she would use graph A. Samantha should use this graph for her presentation because the sales, see, I don't know what that blank's supposed to be. Let's go ahead and look at this. Because the sales appear to increase less. Okay. Now, again, these two graphs show the exact same information. But what's the difference? Well, look at the scaling on the Y. You see how the scale on the left graph, graph A, goes up to 80,000, where graph B goes up to 40,000. So the scaling is different, which makes the graph look different. Okay. People try to manipulate graphs all the time, but so it's important for you to pay attention to what they're showing you. In fact, these two graphs, like they say the same information mathematically, but you can skew someone's perspective of the graph by just changing the scaling on it. Okay, that's a very common tactic. Whenever you see graphs in the news or a newspaper or on the internet and stuff like that, almost always they're trying to paint a narrative. So just being aware of that and being aware of like, okay, here they're trying to say something, so they're going to manipulate the graph to support them as best they can. Okay, that's just something people do. Okay, determine the dependence between the quantities for a given graph. Okay, math quiz score. Here we have the x-axis, number of correct answers, total points earned. So what's the dependent variable? Well, the total points earned is the dependent variable. Remember, that's usually your y-axis. So the total points, the points earned depends on the number of correct answers. So that's what you're going to put. The total points, the points earned depends on the number of correct answers. Okay. Drag each label to the correct location on the graph. Not all labels will be used. Sailor's Bay is a boat rental company that offers sailboat rentals for tourists. They charge a certain rate for the rental of a sailboat and an additional hourly fee according to the length of time which the tourist rents the boat. Complete the graph with the appropriate quantities that describe Sailor's Bay's rental charges. Okay, so in this case, let's see. We know we're going to put time down here, but what do you think? Should we do time in days, time in weeks, time in hours? Well, it says they have an hourly fee, right? So time in hours is what you want here. Okay, that's this one. Now, what's the dependent variable? Well, that's the rental charge, right? How much money you're going to pay depends on how much time in hours that you're renting it. Every morning, a bakery makes wheat bread. The staff bakes 20 loaves before the bakery opens at 7 a.m. and then bakes 10 more loaves every half hour for the next 3 hours. If the number of loaves they have finished baking depends on the number of hours that have passed since the bakery opened, what is the range of this relation? again, the range is the dependent variable. So the dependent variable in this case is the number of loaves that are baked. So they bake 20 loaves before you even start. So that's going to be our starting amount, 20. And then they bake 10 more loaves every half hour. So adding 10 each time. Again, the range looks at the dependent variables, the y's in the x and y axis, the y value. Okay, Mr. Jones is driving a truck at a constant speed. The graph below shows the distance traveled in miles with respect to the number of hours traveled. So again, time is our independent variable. That's very common. Dependent variable, in this case, distance. What does the origin represent on this graph? The origin is always 0, 0. So the origin is always 0, 0 when you're looking at x and y axis. In 0 hours, he travels 0 miles. Yep. Tom is parking his car in a parking lot near a supermarket. He learns that the cost of parking is $2 per hour for the first 4 hours. After 4 hours, a maximum fee is reached and the parking charge remains constant. Which graph models the piecewise function for this given situation? So $2 per hour until you've reached 4 hours. Okay, let's see. Might be this one, right? So at 1 hour, that costs $2. At 2 hours, that's going to be $4. At 3 hours, that's going to cost $6. At 4 hours, that's going to cost $8, and then it's constant there, right? So this, I think this one's going to be right. Let's go and check the other ones. This one shows a decreasing price after you've reached 4 hours. That's not correct. Let's see. $2 per hour for the first 4 hours. Maybe this one. This one's showing that if you park for 0, that it still costs 2. Well, that doesn't seem right. This one doesn't seem right either. Okay, not quite. Okay, yep, it's the first one. Great. A 500-gallon water tank drains at a rate of 50 gallons per minute. The amount of water left in the tank depends on the number of minutes it has been draining. What is the range of this relation? So again, the range are the potential y values. So it starts off with 500 gallons. So it can have at most 500 gallons. What's the lowest amount that this tank can have? 0. So we'd say that the y value can be between 0 and 500. Okay, so here's the lowest. 0 is the lowest amount that could be in this tank, and 500 is the greatest amount that can be in this water tank. Which of the following quantities are continuous? Again, continuous means you can basically split it up as small as you want. So a lot of things are continuous. Time is a very continuous variable generally. So are weights and heights, things like that. What about the population of dogs in a village? Can you have like 2.35 dogs? No, you can't have a fractional amount of dogs, right? So this one's definitely not continuous. This is what we'd call discrete. The distance covered by a train, yeah, that's continuous. Okay, that's continuous. Because you can say you could travel 1.3 miles or 1.37 miles or 1.45 miles, right? You can split that up, right? And cut it down smaller and smaller portions, right? So that's continuous. The number of books shelved in the fiction section of the library. No, that's discrete. The number of bracelets sold. No, that's also discrete. So I'm going to say 2 only. Let's look at the graph. Okay, let's see. Productivity of a pen factory. Boxes manufactured, number of hours. Okay, again, time is our independent variable. Okay, which of the following statements are true based on the graph? The number of pens depends on the number of hours. Okay. The number of hours depends on the number of boxes manufactured. No, this is not right, because time does not depend on other things. Time just moves, right? The number of boxes manufactured depends on the number of hours. That's what I would say, right? The number of boxes manufactured depends on the number of hours. Number 10. Rachel is on a hiking trip with her friends. After 3 hours of hiking and at 6 miles from their starting point, they decide to take a 1 hour break to eat lunch and take pictures. After 4 more hours, they reach their campsite 16 miles away from their starting point. Which graph correctly models the situation? So it looks like they hike for 3 hours, and that travels a distance of 6 miles. Then they take a 1 hour break. Then they travel for 4 more hours, which is give us 16 miles away. Okay, so 4 more hours. Okay, so this would be, let's take a look. So this first part, let's look at this. So 3 hours of hiking, travel 6 miles. Let's see, is that true here? No, here it only took them 2 hours of hiking to get 6 miles, so that's not right. Here, this one, it took them 3 hours to travel 6 miles, good. Then they took a 1 hour break where they didn't travel any distance, so that looks good. And then they traveled up to 16 miles and it took them 4 more hours. So I think that's right. I think this one's correct. Let's go ahead and look at the other two just to make sure. Here, this one looks good too. 3 hours, chose 6 miles, then a 1 hour break. Then, oh, they need to be 16 miles away, right? So it should be up here. Let's look at this one. Oh, this one's not right at all. 3 hours, it shows that they traveled 12 miles. No, that's not right. Okay, the weight of a baby every month since birth is indicated by segments A, B, and C on the graph below. Select the segments in the correct order from the least to greatest rate of increase. So rate of increase, that's talking about the slope. So look at this line versus like this line. Which of these has a greater slope? Well, this one does, right? So the steeper the line, that means the greater the slope, or in other words, the greater the rate of change. So we're looking for which one has the lowest rate of change first. Okay, so which one has the lowest slope? I think that's C, right? C is the flattest one. Then B, then A. So in that order, C, B, A. Okay, which makes sense. They grow faster in the beginning, then their growth slows down as time passes, right? They're still growing a lot, but their growth slows down as they get a little bit older. Okay, so now we're on to the mastery test. I have 20 questions here. You're going to be given 5 of these questions. I don't know which 5 you're going to be given, but I will go over every one of these questions, which will cover your questions as well. If you follow along and just kind of watch me go through every one of these, it'll greatly increase your understanding in general. Okay, so I suggest you just kind of follow along. And then when I get to one of your questions, then stop and do the problem and then continue the video. All right, let's go ahead and look at question 1 here. A delivery truck driver charges a fixed base price of $6 for 2 miles. After 2 miles, he charges an additional $2 for every mile. After 6 miles, he charges an additional $4 for every mile. Describe the cost of delivery truck between 1 mile and 2 miles. Okay, so you can see distance in miles here. You can see here between 1 and 2 miles, what's happening to the cost. All right, think about that. John is driving to his office to attend a meeting. In the first 10 minutes, he covers a distance of 1 mile every minute. Then he stops at a local restaurant for 15 minutes to have breakfast. After that, he covers a distance of 0.5 miles every minute, so he slows down. In the next 10 minutes to reach his office, which graph models the piecewise function of this situation? So for the first 10 minutes, covers 1 mile a minute. Okay. Then he stops and doesn't, that's going to be the horizontal line, stops and doesn't move for 15 minutes, right? Because he's eating breakfast. That's actually a fast breakfast. Then he slows down, right? Originally he was going 1 mile a minute. Now he's only going half a mile every minute, okay? So remember so let's say this is a slope of 1. A slope of 1/2 would be like this, right? Less steep. Okay. Try to figure out which of those graphs represents that. The Postal Service charges $2 to ship packages up to 5 ounces. Okay. And 20 cents for each additional ounce up to 20 ounces. After that, 15 cents for each additional ounce. So here's the graph. Okay, so we got the graph here. What is the domain of this relation? So the domain is your independent variable, so your x values. So what x values are possible here? Okay. Well, you could have an x value of 0. Yes. Can you have an x value of 5? Yes. 10? Yes. 35? Yes. 50? Yes. What about 60? Yes. It keeps on going. You could imagine this keeps on going in this way, right? So even values that you can't see can still be in the domain. Okay. So think about which of these basically says that. Rochelle is watching a bug crawl towards her on the sidewalk. As the bug gets closer to her, she stomps her foot to startle the bug, which becomes stationary for some time and then crawls away from her quickly. The graph shows the bug's distance from Rachel. What is the range of the graph? So again, the range is looking at the y-axis, okay? So what's the lowest value in the range? What's the lowest value on that has a point on the y? And what's the highest value in the range in this case? Okay. This is a little bit different than the one we just did. So the one we just did can continue on forever. This one's not really showing that. This one's showing that it has a highest value. Okay. So which of those shows that range? Again, the range, you look at the y values. Consider the following graph. Cheryl's commute. Okay. Speed, miles per hour. Time, minutes. Okay. Which statement best describes Cheryl's commute? Okay, Cheryl drove at a speed of 65 miles per hour for 1 minute, made a stop for 5.5 minutes, and then drove at a speed of 45 miles per hour for 2.5 minutes. Okay, that doesn't seem correct. The one thing to keep in mind here is for the first minute, she's going 65 miles an hour. So that part is true. But then she stops for how much time? So to here, just here. So yes, from 1 to 6.5. So that's 5 points. So this distance is 5.5. Stops for 5.5. Then from 6.5 to 9, Looks like she's driving back. Let's see. Then drove at a speed of 45 miles per hour for 2.5 minutes. Yeah, so this one's going to be this one. So this one shows that she stopped for 5.5 minutes. So that's correct. See how the distance is not increasing, but time is. So time is passing, but she's not actually moving. That's going to be that flat horizontal line in this case. A car wash charges $8 per car and can wash at most 10 cars each hour. The amount the car wash earns in an hour depends on the number of cars washed. What is the domain of this relation? So the domain, again, is the independent variables. In this case, the domain is the number of cars serviced. So they could service at most 10 cars in an hour. So we know that's the highest point in the domain. Okay. So both C and A both say that, right? But what's the difference between A and C? Well, A is discrete, right? 0 cars served, 1 car served, 2 cars served, 3. That's discrete. C is showing continuous. So C includes all fractional parts too. So could you service 1.5 cars, for example? Well, that's what C is showing. Okay, so which of those makes more sense? Should it be discrete or continuous? Okay, and that'll tell you basically what should be the domain in this case. Okay. Rosalie is training for a marathon. She jogs for 30 minutes at a rate of 5 miles per hour. Then she decreases her speed over a period of time and walks for 60 minutes at a rate of 3 miles per hour. What is the range of this relation? Okay. So here we can see, here's our speed versus time. Okay, speed versus time. So for the range, you're going to look at the y values. Remember, domain, you look at x, range, you look at y. Okay, so what's the highest point in the range? What's the lowest point in the range? Okay, see if you figure that out. Ross is studying the rate of change in the velocity of a remote controlled car. He notices that the velocity of the car is increasing at a constant rate. So the velocity is increasing. Which graph shows the fastest rate of change in the velocity of Ross's car? Remember, the steeper the line, the greater the rate of change. Okay. So which of these would have the steepest line? Okay, think about that. Okay. Leandra is renting a car for 1 week. The total cost to rent the car includes a weekly rate plus an additional charge per mile driven. Which graph shows the correct labels for the axes to describe the total costs Leandra will pay to rent the car for 1 week? So here we're just showing what would be the dependent and independent variable. Okay. So does the cost depend on miles driven? Does the cost per mile depend on the weekly rate? Does the total costs depend on the days rented? Or do the weeks rented depend on the total cost? Okay. It's kind of a tricky one, but I'm pretty sure it's A, right? Your cost depends on how many miles you drive for, right? Because there's a weekly rate, but that's a flat rate. That's a constant there. But there's an additional charge per mile. So the cost depends on how many miles you drive. The students in Mrs. Willow's reading class are all reading the same novel independently. 4 students create a graph of their reading rates in words per minute as shown below. Okay, So we have 4 kids, and for some reason they're calculating the number of words per minute they read. Okay, whatever. Okay, okay, so we got 4 graphs. Which student reads the fastest? So we want to see which student has the greatest slope. Now this is a little bit tricky here because take a look at these 4 graphs. They have different axes. Like look at Mason's, his time is in minutes. And the words read is going by like 200 here, right? Whereas like Sarah's here, where Mason has a 1 here, Sarah has a 2 here. You see that? And her y-axis is going by like 300s here. So you have to really pay attention here. Let's look at, I would say, let's look at the 10 or maybe the 5-hour progress for each student, right? Okay, so what would be the 5-hour progress for Charlie here? So 5 hours. So here's 4, here's 8. So 6 belongs here. For Charlie, 5 hours, you would have read, it looks like, what's between here? 1050 plus 700 divided by 2, 875. So Charlie, in 5 hours, he'll read, it looks like 875 words. What about Riley? In 5 hours, that's here. She would have read here, which looks about, so if this is 4,000, then this is 2,000. So she's looking at about 1,000 words, okay? What about this person, Mason? In 5 hours, he's looking at 1,000 words, okay? So he's up here at 1,000 as well. Looks like Riley and Mason are neck and neck. What about for Sarah here? So for 5 hours, that's right here. She's looking at right here. Okay, I think we have a winner here. Yeah, so if this is 900 and this is 1,200, you know, it's more like 1,100 here. Yeah, so it looks like Sarah is our fastest reader. Okay, that was a tricky one. That was a tricky one for sure. Okay, it looks like Charlie has the greatest slope, but actually Charlie was the slowest reader, right? But that's because they changed the axes on each of these graphs. So pretty tricky that one. Roy plans to go boating over the weekend. The boating club charges an initial fee of $30 to rent a boat, with an additional hourly rate for each hour the boat is in use. So $30 flat rate plus an hourly rate. Okay, which graph represents the above situation correctly? So even if you just, let's say you rent the boat and you get on the boat, then you immediately turn around and you return it. They're still going to cost you $30, right? So they charge you $30 up front just to get started, plus there's an hourly rate. So if you take the boat out for some amount of time, you're going to have additional cost. So which one of those graphs best shows that? Think about it. I think you got it. I don't know why they label these graphs W, X, Y, and Z. They should just label them A, B, C, and D, but whatever. Okay, just be careful you click the right one. Which of the following quantities are discrete? So again, discrete means you can't like infinitely divide it or split it into things, right? Okay, so 2 of these are discrete. I'll give you that. 2 are discrete and 2 are continuous, okay? So see if you can figure out which 2 are discrete. A copy shop charges 20 cents per photocopy for orders up to 8 copies. Which graph represents this relation? 20 cents per copy. All right, well, notice the B and D, I'm going to automatically say these are wrong. All right, and the reason why is because they're not discrete. So when it comes to like how many pages you photocopy, that should be discrete, right? You can't photocopy like 1.25 pages, right? So it should be a discrete, your two variables are both discrete in this case. So it's going to be either A or C. I want you to think about 20 cents per photocopy. See if you can figure out which of those graphs shows that. All right. The table shows the cumulative number of minutes Alice practices clarinet for the first part of the school year. Okay, so for the first 2 weeks, she practices 300 minutes and so on, okay? The values will be graphed in the given coordinate plane. Which is the most appropriate choice for the origin and scale of the graph? Okay, so during 0 weeks, we could probably say she graphed 0 minutes, right? So the origin should be 0, 0, I would say. Okay. And then what makes the most sense as far as scaling? Well, we could do 1 week at a time. That's what I would probably do. Or each unit could be 2 weeks at a time. That's fine too. So 2, 4, 6 weeks. Okay. 1 week, I would also say, is probably pretty good. You might have to make this bigger though. And then for the values here, what makes the most sense for the Y values? Well, we wouldn't want to count by ones because we need to get up here to like 1200. So maybe count by hundreds or something like that, or maybe 200s, maybe 50s. Okay. So I would say this one's definitely right. And the reason I know it's right for sure is because the 0, 0. That should be your origin. 0 weeks, 0 practice. Okay. Determine the dependence between the quantities for the given graph. Okay, so which one should we say? Should we say the total cost depends on the weight of the package? Or should we say the weight of the package depends on the total cost? Okay, so in other words, which one's the dependent variable? Whichever one's the dependent variable, that'll go first. Drag each label, okay. Tobias has a job waiting tables where he earns a certain amount every month and an additional amount per table, according to the number of tables he serves. Complete the graph with the appropriate quantities that describe Tobias's earnings over the course of 1 month. Okay. So the amount of money earned, definitely that's going to be our dependent variable. So the amount of money earned depends on what? Which of these makes the most sense as the independent variable? The amount of money earned depends on what? According to this situation. Okay. Paul and his neighbors decided to build a fence along his farm. After 3 hours, they have 15 meters of fence complete. They decide to take a 2-hour break for lunch and then resume building the fence. After 4 more hours, they have a fence that is total of 55 meters long. Construct the graph that models the given situation. So you're going to use this segment tool, but the main thing, we're going to take this one step at a time. So after 3 hours, they have 15 meters of fencing complete. So I would go to 3 hours, comma 15 here. So 3, comma 15. So 3 hours, they have 15 meters of fence. Okay. Then I would just connect here. So make a segment. So use the segment tool and connect 0, 0 to 3, comma 15 like that. Then after that, they decide to take a 2-hour break. So during this time, they're not actually, during the next 2 hours, they're not actually constructing the fence. They're just taking a break. So from 3 to 5, you would make another segment here, make another line segment, connecting from 3, comma 15 to 5, comma 15. Here during this flat section, no progress is happening. After 4 more hours, they have a fence that's 55 meters long. Okay, so after 4 more hours, so from hour 5, we want to go 4 more hours over. 6, 7, 8, 9. And then at 9 hours, they have a fence that's 55 meters long. So all the way up here. So make a segment connecting that. The water level of a tank every minute since it began filling is indicated by the segments A, B, and C on the graph below. Okay, so we could see, okay, we have it's filling the water tank versus time. Time is our independent variable. Place the segments on the correct order from least to greatest rate of increase. So which one has the least rate of increase? Which one has the least rate of increase? Well, remember, the steeper the line, the more the rate. So we're looking for the least rate of increase, or we're looking for the flattest line. So which segment is the flattest, A, B, or C? So whichever one's the flattest, you'll put that first. Then you'll put the next flattest. Then at the end, you'll put the steepest. Okay? Make sure to put in the correct order here. Least to greatest there. Okay. Alanya parks her car in a lot that charges by the quarter hour, so every 15 minutes. The table shows the parking fee in dollars with respect to the time in hours. Okay, so you can see the fee, 50 cents for a quarter hour, $1 after half an hour, and so on. Time is the independent or dependent variable. What do you think? And it should be placed on the x-axis or the y-axis. What do you think? The parking fee is the independent or dependent. It should be placed on which axis? Okay. Throughout this lesson, I talked about time should always be what kind of variable and goes along the which axis. Okay, you should know this. The graphs below show the number of faulty products, Y, produced by a company for the first 8 months since production started. Both graphs show the same information. Okay, so we have the same information here. They're just displayed differently because you can see the axes are different, right? The first one, graph A, the axis goes up to 400, the Y-axis. But in graph B, the Y-axis only goes up to 200. That greatly changes what the graph looks like, doesn't it? Okay, but really these both have the same information. Alex is preparing a report and plans to discuss how there was only a slight decrease in the number of faulty products over the first 8 months. Complete the following sentences. To support her discussion, it would be best for Alex to use blank for her presentation. So if she's trying to show a slight decrease, does it make more sense for her to show graph A or graph B, even though they both have the same information? Alex should use this graph for her presentation because the number of faulty products blank on this graph. Okay, so I want you to think about that. We've done ones like this before. Okay, well, that's the first tutorial, practice, and mastery test for the very first section of Unit 2. If you would like to thank me and you found this useful, then just like, comment, subscribe, or share it with someone else you think would also find it useful, namely your teacher or one of your fellow students. All right, well, with that, thanks for watching. I'll see you next time. Take care.